All right, problem number 2. It says, please answer the question about the graph below. So we want to describe the motion of the object from 0 to 3 seconds. So a couple things I want to note, which is that if your velocity graph is up here, you're going forwards. And if your velocity graph is down here, you're going backwards. That's the first thing. And in fact, this little fact about velocity graphs, I might want to put in my note card. So if we describe the motion of the object from 0 to 3 seconds and then 3 to 10, so from 0 to 3, it's moving backwards at -4 meters per second, or you could just say 4 meters per second. Just the fact that it's backwards, and you know it's negative, but we're not going to worry about that. Just know that it's going backwards. Know that the size of the speed is 4 meters per second. And then from 3 to 10 seconds, we're going forward at 2 meters per second. And this is all steady or constant velocity. Okay. Now, the displacement of the object from 0 to 3 seconds. To be clear, to get the area, I draw a line from this t-axis, this time axis, to the curve. So I'm going to actually calculate the area here. So the area from 0 to 3 seconds, it's the area of a rectangle. Now I'm grabbing this formula from the front of the test, and that's going to be here. Length is -4, and width is 3. So I'm getting 3 times -4, which is -12 meters. So one thing I would note is that for velocity graphs, and we're going to get to this a little bit later, but this is some good things to note. And in fact, I might want to put this in my index card. So for velocity graphs, first, the area gives you the displacement, and the slope tells you the acceleration. You notice here how the slope is 0. That means we're not accelerating and we're moving at a constant rate. Now the total displacement of the object, and in fact, just let me make a little note here that this is something for the note card. All right. Now the total displacement of the object, I need to get, so I had this -12 from before, plus I'm going to get this area here. So this goes from 3 to 10. So this width is 7 seconds. I'm taking the 10 here, and I'm minusing the 3 to get 7. And then we have this length of 2. So that's going to be plus 14, because what I'm doing here is I'm taking 7 times 2, and that's getting me 14. 7, times 2. And so that's giving me a displacement of 2 meters. Now, it says plot the position of the object from 0 to 10 seconds, assuming it starts at the 20-meter mark. Let's be really clear. Maybe this is another note for the index card. Okay, so what I'll say is this. When plotting a position graph from a velocity graph, the V values are the slope of the position graph. Let me be really clear. So on this thing from 0 to 3 seconds, my slope is -2. Or -4. In other words, the velocity is -4. That means the slope on this graph is -4. So from 0 to 3, my velocity is -4. So slope equals -4. And I'm really going to use that as a rise over run. And then from 3 to 10 seconds, my slope is 2. So I'm starting from 20, so I'm going to start here. And I'm going to just blow this up so you can see a little bit better. Did I blow it? Oh my goodness, I blow it up too much. All right, so there we go. So I'm going to go over 1 and down 4 to 16. Over 1, down 4 to 12. Over 1, down 4 to 8. So that's the first part. And I'll give you rulers on the test, but this is how we sketch that in. All right. Now, from 3 to 10, my slope is 2. So I'm going to go over 1, up 2, 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 over 1, and up 2 to the end. And then I'll connect this. All right, so that's how we use the velocity graph here to get a position graph here. So I give you the starting position, you start there, and then you use these velocities as rises over runs to figure out how to draw the graph. So that's question number 2.